Hi guys, today I thought I was going to do a fun video. I'm going to try and finish this whole 2019 electricity physics paper in under 15 minutes. So by the time this recording cuts off, that's when I'm going to end. So whatever question I get up to is where I'm going to finish. I'm going to hopefully I can speed run this super well without the help of any marking schedules or anything, just purely based on the knowledge I have. So I've got this timer here, and or I've got the timer from the recording, so we don't even need this. So let's not worry about that, and let's just go. So I'm gonna, for the explain questions, I'm not even gonna bother writing a paragraph. I'm just gonna go as quick as I can. So, 4 volts, show that the circuit current is 0.8. Okay, so if that's 4 volts, then that just means V equals IR, so I equals 4 divided by this, 5, that's 0.8 amps. Alright, next. Calculate the heat energy dissipated in 2 minutes by the resistor, that's 120 seconds. Heat energy is E equals PT, P equals IV. The voltage of the resistor, if that's taking up 4 volts and these 15 volts, that means it has to be 11 volts, so it's going to be P equals the current, which is 0.8, and that applies to that because it's in series. So 0.8 times 11, P equals 8.8 watts, E equals 8.8 times 120. And what does that equal? And put that in my calculator. 8.8 times 120. That's 1056. Alright, 1056 joules. Next. Right, next question. Another part of a circuit in the lamp is shown below. Calculate the total resistance. Alright, so it looks like we've got a parallel branch here, so I'm just going to combine that. That's going to equal 11.6. So R total equals 1 over 11.6 plus 1 over 3.2 to negative 1. R total equals, well, it's going to take a while to plug in, 11.6 plus 1 over 3.2 to the negative 1. That's going to give me 2.508. So 2.508. So RT equals 2.51 ohms. Right, next. Come on. Oh, this is going to take forever. Blah, 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 blah. All lamps are identical. Circuit 2 has an extra lamp, which is here. By considering the combined brightness, blah, blah, blah. Alright, total brightness of circuit 1 to circuit 2. So, I'm just going to cover the main points. So, extra lamp in C2 means total resistance is going to decrease, because in parallel, that's just how things work. In parallel, if you add bulbs, the total resistance is going to decrease. If you take away lamps or bulbs, the total resistance is going to increase. So since V equals IR and the voltage supply of 12 is fixed, that means if R goes down, then I has to go up to keep it at that 12 volts. So P equals IV, and P is linked to brightness. If I goes up, oh my goodness, and V fixed, then P increases, so B increases, so C2 brighter. Oh, alright, let's go. 3 minute, 50 seconds in. Calculate strength of the electric field. Right, so E equals V over D equals the voltage. That's going to be 550,000 divided by, yep, it's in the right unit. So 550,000 divided by 1.2. Oh, that's a really ugly number. 458,333 dot 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 dot. So I'm gonna round that to 4.6 times 10 to the how many? So 1, 2, 3, 4, 5. So 5 Vm minus 1. Next, during one test, the rocket was initially moving at speed blah, 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 and stopped in the distance D. Explain in depth what would happen to the stopping distance if the rocket was tested again. Alright, double the initial speed. Alright, what formula? Oh, I know, okay. So EK equals half mv squared. M and... oh no, just M. M is constant. So if V doubles, then EK quadruples because it's squared. Then I can go EK equals EP, EP equals EQD, and E and Q constant. Yeah, wait, electric field strength. Yeah, electric field strength is constant. So if EP is times 4, then that means D has to be times 4 or quadrupled. That should be right. I don't really have much faith in that. That might be wrong, but oh well. Draw the field lines. Okay. Okay. Oh, okay. I'll take my time. Curved bit here, positive. So draw my lines. Make sure they're evenly spaced. Oh, okay. I'm gonna rub that out. That's not good enough. There, and make sure they're pointing from positive to negative. Okay, it's a really ugly field line, but it works. Next. Maximum stopping distance is 1.2 meters. What is the maximum speed that a rocket can still be moving? Okay, so EK equals EP. EP equals EQD. EP equals the electric field strength, 4.610. Was it 4.6 times 10 to the 5? Yeah, it was. And the charge is 3.5 times 10 to the negative 6. Times 10 to the negative 6 times the distance 1.2. So if I put that into my calculator, 4.6 10 to the 5 times 3.5 to the negative 6 times 1.2. It's going to give me 1.932 joules. So EK equals 1.932 joules. V equals square root 2EK divided by MV equals square root of 2 times 1.932 divided by the mass, which is 130 grams. So what's that going to be? 130 divided by 1,000. That's going to be 0.13. 0.13. So V equals, so square root of 2 times 1.932 divided by 0.1. That is 5.45 dot dot dot. So V equals 5.5. Alright, there we go. Alright, one more question to go. Let's go. Question 3, magnetic fields. Okay, all this. Show that the voltage induced is that V equals BVL. V equals magnetic field strength 47.3 times 10 to the negative 6 times 13.5 times the length, which is 42 centimeters converted to meters. That is 0.42. So V equals, oh, I need the unrounded answer. That's the annoying thing. 47.3. Oh no, I have 7 minutes left. Oh, I should be fine then. Times 13.5 times 0.42. Okay, yep. I get 2.68191 10 to the negative 4. So V equals 2.68 times 10 to the negative 4 volts. Easy. Oh no, give an in-depth explanation of how a voltage is induced. Right, so the handlebar has electrons in it which cut the B field or the magnetic field. Just writing B to save time. So the E will be pushed towards, if I use my right hand rule really quick, into the page, so fingers away from me, and it's going right, so my thumb to the right, so the force is going up, but for electrons it's going to be the opposite, so push towards the bottom. So bottom is negatively charged and top is positive, so charge separation equals induced voltage. Easy. Next. Right. The student then rides up a steep hill, blah, blah, blah. What is the effect of riding up this hill on the value of the induced voltage? Alright, that's going to be less because For the voltage to be maximum, it needs to be directly perpendicular or 90 degrees. The more, closer it is to being aligned, the less the voltage or force will be. Explain fully your answer to part I above. Just what I said. Max voltage / force takes place when the bike is 90 degrees / perpendicular to the B field, magnetic field. Since it is now less perpendicular, there is less induced voltage, as when it is in line with the B field, voltage equals 0, force equals 0. Okay, 4 minutes to go. Is this the last question? Oh, wow, sweet, I've done really well. The student after an after school where they move a 1.5 meter pipe through a 0.8 width of that. Alright, there's a resistance. That just tells me I need to find a voltage before I can find a current. Calculate the force that the student needs to exert in order to keep the pipe moving at 3.1 at right angles. Okay, first I'm going to find the voltage because I need that. Because I need F equals BIL. I don't have that, but to find that, I need V over R. And I don't have the voltage either. So I'm going to use V equals BVL. V equals 0.8. What's the speed? 3.1. 0.8 times 3.1 times the length inside the magnetic field, so it's going to be that. I'm not going to worry about the 1.5. 1.2. That's gone. What is going on? So V equals 0.8 times 3.1 times 1.2. That's going to be 2.976 volts. I equals 2.976 divided by the resistance, which was 5 divided by 5. So I equals answer divided by 5. 0.5952. Going back up here, F equals 0.8 magnetic field times 0.5952 times 1.2, because it's anything that's within the magnetic field. That's actually gone out, but whatever. So F equals 0.8 times 0.5952 times 1.2. That's going to equal 0.571392. So F equals 0.57 newtons. Done. 13 minutes and 12 seconds. Wow. I probably got a couple wrong because I was going too fast. I probably missed out on some info, but if you're watching this, you can tell me in the comments what I got because I'm not bothered marking myself. That should be right. I'm just going to do a quick check since I've still got 2 minutes. That looks good. That's a terrible drawing. This one, I don't know if that's right. I feel like it's not, but it might be. I don't know. Because I can't think of any other formula that's got velocity in it apart from the EK one. And then I guess I can link it to the conservation. I don't know. That's got to be right. This, yeah, parallel, yeah, that looks good. This looks good. That's really easy. That, yeah, 11 volts. Wait, I did this calculation in my head. Let me just check if that's right. 0.11 times. Okay, good, it is. 8.8. Yeah, that's good. So, a solid attempt. I think this paper was actually really easy compared to the other papers that I've done. I think this is a very, easy paper. Very basic, repetitive questions that pop up a lot. So, yeah, that's it. I hope you enjoyed this, different tutorial. Cheers.